Hello and welcome. In this demonstration, we'll show how Exostiv can be used to run repeating interrupted captures to increase the visibility and reach over time on an FPGA running at speed of operation. Next to me, I have a running setup with an FPGA board connected to an Exostiv probe through 3 transceivers. The setup provides, in this case, a total bandwidth of 15 gigabit per second. For this demonstration, I'll be extracting data from a SDI video interface implemented in this FPGA. You can see from this first short capture that this video interface includes a start of frame signal, vertical and horizontal blanking signals, a line counter, and the red, green, and blue components, actually 10 bits values represented as analog waves. Say that we would like to observe what happens on this interface at the beginning of each frame. The first step to do this is to define a triggering condition to start a capture when there is a pulse on the start of frame signal, now in yellow in the waveform window. So, let's add this signal start of frame in the sensitivity list of the trigger, and let's define a rising edge condition for this signal in the trigger window. I am now defining the number of times I would like to capture data. Let's capture data for the next 650 triggers, or in other words, the next 650 frames. And for each frame, I'm going to capture a little more than 26,000 samples with a trigger positioned after 19,000 samples in each capture. Okay, let's start. Exostiv is capturing data from the FPGA as I speak. You can see the number of captured frames on this progress bar and the elapsed time on the timer overlay. So now the captured data spans over 11 seconds. On the waveform display, we can see that we have indeed 650 captures. If we zoom in, we can see that the background color changes from black to gray and back for each capture, and that the red dotted lines are the triggers. They are numbered. If we zoom more, we can see that the trigger is indeed on the rising edge of the starter frame. Now, if we zoom out, we can check that we have positioned the trigger with 19,000 samples before it. Yes, as you can see on the scale above. This is indeed the number that we have specified for the pre-triggering. If we check the end of each capture, we should find about 7,000 samples after the trigger, because the total is 26,000 with 19,000 before the trigger. That's what you see on the top scale of this window. Finally, we can check that we have indeed collected 650 triggers. They are numbered from 0 to 649. Now we are going to use data qualification. Data qualification or data filtering allows you to specify a logic condition on the sampled data to filter what you capture. As you can see from the waveform window, we have a line counter in our data. Say that we are interested in a specific line of each frame of the video stream only. Well, by using data qualification, we can add a filter in Exostiv IP so that we discard any data that does not belong to that specific line. We have now added the line counter in the trigger sensitivity lists, and we have specified the line number as a qualification condition. Now let's run the capture again until the end. Yes, that's it. Wave encoding, and there are the results. We can see from the waveforms that only line 68 was captured. Actually, the waveform window displays the line counter as a decimal number, whereas the qualification condition was provided in hexadecimal. So if I switch the conditions radix to decimal, I can see that it is indeed 68 in decimal. Now if I specify 44 in decimal and run it again, let's wait until the end. Yes, you can see in the result that we have only captured line 44 decimal. As a summary, if this represents the time during which your FPGA is in operation, running interrupted captures with triggers and data qualification allows you to concentrate on specific areas of interest of this timeline and lets you discard the useless information. Using interrupted captures with Exostiv has many benefits. First, it increases your reach over the FPGA in operation. With the 8 GB buffer provided in Exostiv probe, your capture can span over hours. Second, if you concentrate on areas of interest of the FPGA timeline, you can reduce the total quantity of data that you need to analyze compared to a continuous capture. And finally, this approach will help you make the most of the bandwidth and the memory resources provided by Exostiv. We've reached the end of this presentation. Thank you very much for watching. Bye bye now.